Here's another polar curve free response question. This one was given in 2018. This is number 5. So this gives us this graphs of the polar curves r equals 4, r equals 3 plus 2 cosine theta are shown. Curves intersect at pi over 3 and 5 pi over 3. R equals 4 is a circle of radius 4. That's this one right here. This is, I forget the category of what this polar curve is called. Not cardioid, I think, or maybe it is. I don't remember the names. Not important, but that's this one over here. This one over here. This is the circle, r equals 4, okay? Let R be the shaded region that is inside the graph of r equals 4, and also outside the graph of r equals 3 plus 2 cosine theta. Write an expression involving an integral for the area of R. Okay, so that's why they give us these limits of integration. We're going to start at pi over 3, and we're going to stop at 5 pi over 3 over here. Okay, so the area of the circular region from pi over 3 to 5 pi over 3 would include over here. Okay, so it'll be half r squared d theta, so r would be this one, okay? And then we're going to subtract this area over here. That's white. Okay, so as I was saying, the area of r equals 4 from pi over 3 to 5 pi over 3 would include this over here, okay? But we're going to cut it off. We're going to subtract it. So we're going to subtract half r squared d theta, where r is this one. Okay, so that's the setup. Half integral from pi over 3 to 5 pi over 3, the outer one per se, 4 squared, minus the inner one, which is 3 plus 2 cosine theta quantity squared. Okay, so you think of it as subtracting areas. Kind of like the upper curve minus the lower curve for non-polar curves, okay? Similar idea. Find the slope. So we right expression, so that's good enough. We know how to solve it. And we probably don't want to solve it. It's very tedious. Okay. Find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. So how do we do that? Do we remember the formula? I honestly don't remember the complicated formula, so I know that x is r cosine theta, where r is, they give us right here, right? That's here, which I simplified to 3 cosine theta plus 2 cosine squared theta. And y is r sine theta, so plug in r, okay? So simplifies to this. I use the trig identity, so the differentiation is easy. So this, we should remember, this is the not as complicated formula, okay? So dy dx is dy d theta over dx dθ. Exact same thing as for parametric equations. Polar equations are just a special case of parametric equations, okay? So dy d theta, we differentiate this with respect to theta. That's right there. Don't forget the chain rule, okay? Or here you use product rule if you do it from here, okay? And then dx d theta, that's right there, okay? So we evaluate it at theta equals pi over 2. The answer should be 2/3. Okay, by the way, let me look at the scoring guidelines. I keep forgetting what's important to write. So, constant and limits of integration are 1 point, and the integrand itself is 1 point. Okay, so I directly did dy d theta dx, so the scoring guidelines, I'm not sure what they will allow. If they will allow this, see, that's why I'm doing it live. This is honestly easier for me because I don't have the formula memorized. If you have the formula memorized, great, but this is how you derive the formula, actually. I just plugged in everything instead. So if I were to get the points, then this is 1 point, dy d theta, dx d theta is 1 point. The division of the two is 1 point in itself, okay? And then the answer 2/3 is 1 point. Okay, so they're not clear as to whether you have to actually derive the generic formula in terms of r and theta, but I plugged everything in, so I feel like I should get the points. Okay, now part C. Particle moves along the portion of the curve, r equals 3 plus 2 cosine there, theta is between 0 and pi over 2. Particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Find the rate at which the angle theta changes with respect to time at the instant when the position of the particle corresponds to theta equals pi over 3. Indicate units of measure. See, you need units here. Don't forget that, okay? So, this is a related rates problem, okay? So, this constant rate of 3 units per second, what is it? Distance between the particle and the origin increasing at a rate of this. This is dr dt. R is the distance from the origin. So this is the rate of change of it with respect to time, so dr dt, okay? It's asking for d theta dt, the rate at which theta changes with respect to time. Okay, so, and they give us theta is pi over 3. Okay, so we need to differentiate this with respect to time, implicit differentiation. Okay, so by the way, I wrote a hat there. So we differentiate, dr dt is, derivative of 3 is just 0. Here is minus 2 sine theta times d theta dt. Plug everything in. Dr dt, they gave us as 3. Theta, they gave us as pi over 3. We want d theta dt. We solve for d theta dt. Honestly, I would just leave it at this, but you can simplify to minus root 3 radians per second. That's the units. Theta is measured in radians, as is given here. Time was in seconds. So, radians per second. And that's the answer for part C. Pretty simple if we were able to recognize it's just a related rates problem. Okay? Alright, that's it for this video. Hopefully it was helpful. This area problem here is very standard. This one, if you don't remember the formula, honestly, I would not bother memorizing the formula. I would just do it like how I did it here. Instead of just memorizing a formula that's way too complicated and high risk for error, memorizing it wrong. Okay? Yeah, as I was saying, please give this video a like if you found it helpful in any way, and hopefully I'll see you in another video as well. Bye.